Okay, right. Now we are going to talk about the analysis of a 12 pulse rectifier. Okay, right. The analysis of a 12 pulse converter can be simplified by considering that a thyristor triggered at the instant that it becomes forward biased is acting as a diode would. Replacing the thyristor in a 12 pulse group as shown in the previous figure will result in a 12 pulse rectifier that can then be used to analyze the currents and voltages encountered in such a topology as shown in figure 1.4, simply meaning we are going to swap out our thyristors for diodes. That's essentially what it means. Okay, this is another concept that will be useful in such an analysis. Okay, this is another concept that is useful in such an analysis is phase notation. Okay, now we're going to now discuss phase notation. Okay, all right. Phase notation is used to indicate the phase relation between the windings of transformers. This entails marking the starting end of a winding with a symbol. The starting end, simply meaning wherever the winding is starting, we will mark that with a dot, double dot, or triple dot, or an asterisk, a triangle, and so forth. All windings on the same leg of a transformer share the same symbol and are all marked on the side that the winding was started. Imagine that you have to make a winding. You will grab hold of the starting point of the wire and then wind the wire around a hollow object. When you have wound the required number of turns on the winding, you will cut the wire and secure it so it does not unwind. You now have a winding with two ends. If you always wind in the same direction and then construct a transformer with the windings, there will be a phase relationship between the starting ends of the windings on the same leg of a transformer. Thus, phase notation of windings only has a purpose if the notation is on the side of the winding symbol. Placing the phase notation symbol in the middle of the winding reduces the usefulness of this convention. Thus, phase notation of the winding only has a purpose if the notation is on the side of the winding symbol. Right. Here we can see, here's the correct manner of using phase notation. Kindly note where the triangle is, kindly note where the dot is, and kindly note where the asterisk is. Okay, this is for the primary star side. Note our secondary delta. Note where the triangle is, note where the asterisk is, equally so note where the dot is. Okay, the diode currents in each half bridge leg have exactly the same shape, but a phase shifted by 120 degrees from one leg to another. Okay, because remember that if you look at this winding and you look at this winding, the difference between the two is about 120 degrees. So that is why they say the diode currents in each half bridge leg have exactly the same shape, but are phase shifted by 120 degrees from one leg to another. The numbering of the diodes is in the order that the diodes will conduct in each cycle of the supply. Okay, since the interest at any moment is to determine the shape of the diode currents in a leg, it is only necessary to determine that of diode D1 and D4. Okay, and since the one pulse rectifier, the one Since the 1/6 pulse rectifier is fed from a star secondary and the other from a delta secondary, the diodes are denoted with a subscript S for star and subscript D for delta. Here we will notice D1 subscript S, D4 subscript S, D1 subscript D for delta, D4 subscript D for delta, subscript S for star. Okay, right? Since the interest at the moment is to determine okay, right? Since the interest at the moment is to determine the shape of the diode currents in a leg, it is only necessary to determine that of diode 1. Since the interest at the moment is to determine the shape of the diode currents in a leg, okay, it is only necessary to determine that of diode 1 and 4. Since the 1/6 pulse rectifier is fed from a star secondary, okay, and the other from a delta secondary, the diodes are denoted with a subscript S for star and subscript D for delta. Okay, so essentially speaking, we will have D subscript 1S indicating star, okay, that will be diode 1, and then this over here will be diode 4, okay,